Q1 depends on Q2, and you know that Q2 depends on Q3, our system can say, okay, so you get new law that Q1 depends on Q3, and in fact, it is new, and it is not that obvious it works, so someone should check this. If it is not true, it means that either law 1 or law 2 was wrong. Okay, so it is also some hint what can be checked, okay, what we can measure. And the other way of obtaining new knowledge is reasoning which we call reverse inheritance. For example, in our application, you can walk through ontology and check whether there is some law which governs. Okay, so you can imagine that you go to C1 and you see, okay, there is no law which governs this C1. Okay, concept. But our system knows that there are two subclasses. Okay, and C2 and C3. So, for instance, in our ontology, sensory attribute is not governed by any law, but two of its subclasses, like gift color, gift tenderness, are governed by some law. So our system says, okay, if you are here, says, okay, we don't have any law which governs the all instances of this class, but some of them are governed by this law, and some of them are governed by this law. So it is also useful to know this. So here is our application. It is accessible through internet. If we have time, I can show that it works. I hope our students are not updating anything now. Okay, so here's this application. So you can see beef. In the first tab, you get all information about beef. So it's placed in the taxonomy. Okay, the red guys come from Dodge ontology. Okay, then you got children of this class and some other ontological connections. Of course, you can click everything. So you can go to some other class. You can go to me, for instance. Okay, to languages. Okay. Here. And here you've got in the second tab. There are articles which are about these things, about me. Okay, so you can see that. Divided in pieces. Okay, this graphical representation is not the best anyway. And there are some theses which are about this class, inferred theses by transitivity, and theses which come from the subclasses. In this case, you can see theses, the representation. Green ones are accepted, red ones are rejected. Okay. So it works. We've got some link open data connections. So if you are curious what Agravoc or Janet says about meat, you can just click and go and see. Okay, if you are curious. Okay, so here we have that link open data connections. Conclusions. So I have presented an ontology of scientific laws and simple reasoning methods for obtaining knowledge from one explicitly written in the ontology. What we are planning to do now, of course, work more, evaluation, verification, testing, add some more theses to our ontology. Currently we've got only 50, just to check what is going on, but if we have more, our inference could provide better and less obvious results. Also, we can improve searching, because now, as you can see, you have access to the papers through ontological classes. Okay, so you just walk through ontology and say, okay, you are in meat, and you have all papers about meat. Okay, you go to sensory attribute, you have all papers about sensory attribute. But now, having this science ontology, you can ask, okay, show me all classes which are about sensory attribute, in which sensory attribute is dependent parameter. Okay, so you get more sensitive search. Okay, and currently we're working on linking the database of results of experiments, so real data with ontology, so you will be able to access to the real data through ontology. And since our ontology is dominant or connected with science, we hope we will be able to test whether statements, proved or disproved statements, are really true. Okay, so our system should go to data and check whether the data justifies, confirms the statement or rejects. Okay, that's all.
So you have designed this ontology. Did you use some existing ontology for this?
No.
So did you
really
publish this ontology?
It's completely open. If you go to the paper, which is published, there's a link to it.
And is the process of finding these laws was reading papers? So people were involved.
60 people were reading papers. So it's the power of human beings.
And what about...
They were paid for that. So.
Okay. And what about different interpretation? Because in this sentence where you have this methodological law, there is this whatever methodology aids in prediction of and then something. But for example, the prediction is not part of any axiom that you show. So the prediction. So you said the sensor and the beef tenderness, but the prediction is missing in this law. So I'm wondering about this interpretation that people when they see this sentence.
Yeah, in fact, there are two interpretations, because first is interpretation of people who are reading papers and extracting the results. Anyway, we don't have a choice, we just trust them that they know what they do. And the second interpretation is done by ontologists, okay, like me, because sometimes the statements were really ambiguous, so we have to interpret them once again, go to the paper and try to really understand what they meant writing this short statement.
And another thing, I think it would be quite interesting to have people annotate their papers with these laws.
Yeah, we plan to do that, in fact, because annotation of papers by laws is one of our goals now. Because
maybe people wouldn't annotate them with this law that you found.
Yeah, it would be absolutely perfect, because if you assign, a statement or the law to paper, you really have good knowledge about this paper. Okay, it's a very good summary of what is inside. Okay? So I believe we work on that.
That you have published the methodology. Is it under a public namespace that anyone can access or can use? So suppose that, for example, in Greece we have the same problem. And we would like to use a domain-specific methodology that is about beef. Would we reuse your methodology?
Okay. In fact, we have linked open data connections to other ontologies, but we did not make our ontology available in the same way, okay? Because it is still under development, okay? So we don't want to sell people something that is still not validated, okay? But obviously we've got one more year to do that, so in 1 year we should join this open data community with our stuff.
This is very interesting, but I'm trying to understand, because I see that the goal of the project is from fork to farm,
yeah.
And I assume that it is to lower the distance from farm to farm, or to make more transparent this.
I mean,
this
hunters. In fact, they describe the process, the whole process. And the point is that there are many guys, and it's really surprising if they don't really know what others are doing. So you guys have some consumer tests, okay? So they give beef to the people, they say, okay, it's good or bad, okay? There are guys who kill animals, okay? They don't know about each other, okay? And in the project, they have, say, stages. At each stage, there are guys who do things, and in fact, our dream is that our ontology will link them somehow, so they will see that they exist, okay? That the results from let's say, insemination process is very important to the taste of steak which you get on your table, okay? So, in fact, they dream about about improvement of quality of meat which you have on your plate by improving some phase which is before at the level of killing, feeding, whatever. Okay.
This is nice because I know from father to fork, but I first time I see fork to father. It's interesting.
In this community is pretty
it's the reverse.
common. It was a very big project pro safe beef. It sounds similar. It's a kind of copy or continuation, okay? And they discovered that it's really important to really take care about the quality at each stage, okay? For example, I was really surprised to know that, let's say, the correct killing of animals is very important to the taste of meat. If you do something wrong, okay, in this process of killing, for example, there was a problem, 50% of meat was just had a pH, too high pH, because animals were stressed, okay? Because they see something, you know, how one before was killed, or they hear something, some noise which was scary for them, okay? So all of these small factors are very important for the quality of meat. So they discovered it. It's a huge money which is in this field.
Okay, thank you. Okay, our last presentation is titled Semantic Share Spaces for Task Allocation in a Robotic Fleet for Precision Agriculture. The presenter is Tuma Nayak. Sorry, currently he's doing the PhD at the University of Technology in Vienna, and his research interest is using semantics for coordination and adaptive autonomy in robotic fleets.
Hello everyone, I will have a presentation on semantic shared spaces for task allocation in a robotic fleet, which is used in a precision agriculture scenario. So first of all, I will say a few words about task allocation. I will follow it with describing precision farming as a motivating scenario for this work. We proceeded with the introduction to the space-based paradigm and presenting the semantic extension of the one representative of the space-based paradigm called motor spaces. We also use motor spaces to do some efficiency measurements. Basically, we had two use cases which are extended from our precision farming in this case. And I will wrap up the whole presentation with the conclusion and the future work. So basically, recent advances in robotic technology enable the transition from homogeneous robots to heterogeneous robots, which now operate in unstructured and volatile environments, which consist of very different types of tasks. And since there are different types of tasks in those unstructured environments, the problem of task allocation arises, which actually search for a solution how to optimally map a set of robots to a set of tasks, or which robot will execute which task. And this is becoming a fundamental problem in all multi-robot systems where the heterogeneous robots are applied. And how do we tackle this allocation problem in our work? So we decided to combine semantic technology with the space-based middleware, and as a result, we got a framework which translates resource data into a semantic model, and since resource data are translated into a semantic model, we can do some reasoning in order to better match services offered by robots on the one hand